All right. Hello, everyone, and welcome to the VIS session on text annotation and metaphor. I'm your session chair, Melanie Torre, and we're going to get started right away. We are going to monitor questions in Slido, so please get your questions in during the talk so they can get uploaded and be ready to be asked right at the end. Our first speaker is Chase Stokes. And the title of the talk is The Role of Text in Visualizations, How Annotations Shape Perceptions of Bias and Influence Predictions. Go ahead, Chase.
Awesome. Thanks, Melanie. And thanks you all for your attention this morning. I'm really excited for this session and I'm delighted to be able to kick it off. So my name is Chase Stokes. I'm a fourth year PhD candidate at the School of Information at UC Berkeley. There, I'm advised by Marti Hearst, and today I'll be talking about some recent work we completed with Cindy Bearfield from Georgia Tech. So when visuals and text are shown together, readers tend to focus on text quite often, spending particular attention on visualization titles and relying on them during information recall. They also tend to use this text to inform their takeaways from a visualization, whether that be from a caption, a title, or an annotation. However, telling a reader information about the data can also obscure other parts of the chart. So in this example, highlighting the points between the Labor and Conservative parties led fewer readers to notice features of the Alliance and United parties. So including text information on this chart might be able to signal some kind of potential bias from the designer. Readers also do more with visualizations than just make conclusions. They use data to make decisions and predictions about future data states. So in this study, we were specifically interested in the effect of text on predictions a reader would make about the future state of the data and the appraisal of the possible bias from the visualization creator. In this context, we're defining bias as favoring one side or idea without sufficient justification. Visualizations can be skewed to highlight one pattern over another, and text could be a useful tool for that kind of manipulation. However, we know very little about how text affects perceptions of bias from the chart, as examinations of bias and trust is a budding field in visualization. In order to study predictions, we use relatively neutral examples. So this bar chart shows 3 years of a fictional student government election with a blank space for year 4. This chart is specifically designed to be ambiguous. So if participants notice the predominance of blue, they would predict blue to win in year 4. But if they notice the steady increase of green, they would predict green to win in year 4. And we can actually bring that text, use text to bring that story to the forefront of reader attention and highlight those patterns in the chart. We also used a line chart, which uses the same kind of basic patterns for comparison for chart type and topic. So you can see here the blue company is winning for the duration of the existing data, but the green company is rising. And here we're using the event day as the prediction point, or that kind of dotted gray line. And we conducted 2 studies, both examining these central research questions, one about predictions and one about perceptions of author bias. We also asked sub-questions about how variations in text content and position would affect predictions and perceptions of bias. So in study 1, we used the 4 semantic levels from Arvin's work and mostly focused on L2 through L4, which conveyed statistical, perceptual, and external information. And in study 2, we collected crowdsourced annotations, which were then rated on a scale of bias and sorted into high bias, low bias, and text which did not take a side. In terms of position, we used the title and annotation position, similar to those tested in prior works. The general survey flow was the same for both studies as well. So we collected crowdsourced participants from Prolific with 640 completed study 1 and 660 completing study 2. The participants viewed a single chart selected from our set of stimuli options for the study. They predicted which of the 2 groups they expected to have a greater value at the given future point in the chart. And the language here is for the bar chart, hence the party and election terms, so it would be company and event day terms. And in addition to a binary choice, participants also rated how likely the prediction was. So we used this question as a proxy of confidence in the decision. Higher perceived likelihood indicated greater confidence. They then went on to rate the bias of a given chart using a set of different scales modeled off of previous work in assessing media bias. We used only a scalar measure here since we were interested in capturing neutrality or when people thought there was not bias. But in the prediction case, we really wanted it to be kind of a forced decision. Addressing our research questions will require us to think of participant responses in relation to the text provided on the chart. So in this example, we have a line chart which reads green market share increases steadily and our 2 competing companies as options to win on event day. And if a participant selected that green would have a higher market share on event day, then we consider that prediction to be aligned with the text. If they had selected blue, the prediction would have been unaligned. Essentially, we're capturing whether the response matches the outcome that's supported by the text. And we use the same basic concept with the bias appraisals. Here we used matched and unmatched just to differentiate between the 2, but it's essentially the same idea. So here we're looking to see whether participants are identifying the ground truth bias of the author, so which side that text is supporting. So let's look at our first research question. Since text has been shown to have an effect on takeaways, we did expect there to be a high amount of aligned predictions. We also expected confidence to be higher for aligned predictions than unaligned predictions or control conditions, since the prediction was supported by the text. We kind of thought if you saw the text supporting green, you would predict green. I don't have time to get into all of the statistics here, but they can all be found in the paper, and our tests were pre-registered on OSF, which is also linked in the paper. Essentially, we saw pretty inconsistent results across the two studies and different chart types and our different ways of eliciting predictions. So in study one, the bar chart had a small but significant effect on binary predictions, but no effect on the scalar confidence ratings. However, the inverse was true for line charts. So here you kind of see that inconsistency. And in study two, we also observed some inconsistent findings, and these tended to have really small effect sizes if they were significant. We did not find any differences between the semantic levels nor the title versus the annotation's position. In study two, we did find that text with lower bias ratings had a stronger effect than neutral or biased text, but as in the case of many of these findings, this was not consistent across chart types and only applied to line charts. So as a whole, even though you do get kind of an aggregate effect maybe here, I would say that this text has a really small effect on prediction, if any. This is not the kind of impact we'd observed for takeaways in prior work, and this was not only surprising to us, but important to find as we can kind of start to lay out the specific impacts of text elements. So if text didn't have a strong effect on prediction, what does it do, right? Let's turn to our second research question. And we did extract binary information out of the scalar responses just so we can make kind of similar comparisons. But in doing this, we still accounted for participants who rated the chart as relatively neutral. Here is where we see a really strong and consistent effect. So across both studies, chart types, and ways of examining the data, we found that text indicates a strong signal of bias. That is, participants were likely to identify that the author was biased towards the group that the text supported against the other group, and even that the author belonged to the group supported in the text. Some text content was also more influential here. So specifically, including external information led to higher rates of matched appraisals, indicating that text that brings up some kind of contextual event may be a larger signal of bias than text which just describes the data trend. So here you have an example of what that L4 text might have looked like. And high bias annotations also increase perceptions of bias as we would expect, sort of a sanity check there. From all of this, we can conclude that text does have a consistent and strong effect on perceptions of bias, especially in comparison to the lack of effect on predictions. We also conducted some exploratory analyses to better understand the relationship between predictions and appraisals. So when participants' prediction was aligned with the text, they still recognized the overall leaning of the author or the designer of the visualization, but they were rating this bias as relatively low. However, when participant predictions were not aligned with the text, the perceptions of bias were higher. So in other words, take a chart like this with the text supporting green. Participants who predict green will win see the author as only slightly biased, typically just above neutral on average. However, participants who think blue will win look at this chart and see the authors almost twice as biased as the aligned participants. And this difference increases if the text is even more biased. So what you start to see here is two groups pulling away from each other in a situation similar to polarization. This is a neutral chart about a student government election, right? But if this was not a case created for lab testing and was instead a real example of political data, you could imagine the responses looking even more extreme. So if the text on a chart doesn't sway people to predict one group over another, what does? Well, we did collect some qualitative information about the outcome prediction as well, and in examining why people made predictions contrary to the text, the basic justification was essentially that the visuals themselves told a stronger story about who would win. And actually, it turns out that highlighting these visuals with this kind of visual annotation does sway participant outcome predictions. So this is from prior work where we found, or where we used these charts from, and this kind of visual annotation did have an effect on predictions. But simply using color to emphasize a trend does not influence prediction. So just highlighting, one set of bars over another using color did not have an impact on those blue-green predictions in year 4. If you're interested about hearing more of the impact of color and grouping, do kind of check out our talk later today about grouping and color cues in bar charts as well. So given that we know text has little influence of predictions, but a strong impact on readers' perceptions of the author, where can we go from here? Well, we know now that text has different impacts depending on the specific task readers are performing, so future work should explore those additional tasks and questions. We also know that some text signals bias more than others, but it's still not 100% clear why that might be, and we didn't have large enough text corpus to answer this question in this study. And finally, as I mentioned before, this was a set of relatively neutral data. It's not certain how these effects would be consistent in the real-world context, and as such, that should definitely be explored as well. In general, the study illustrates that text does not have universal effects on reader perceptions, and it cannot have adverse effects on perceptions of the designer or the author of the visualization. You can read more details on my website where the paper is linked. I'm currently applying for and seeking jobs in the Chicago area, so if you are someone who's looking to fill a research role in Chicago, I would love to chat further with you. And I also want to include QR codes for donating to help the communities affected by both hurricanes. We have a Tampa-specific organization, but people still need aid and assistance all across the Southeast United States. With that, I want to thank you for your time, and I'd be more than happy to answer any questions.
All right, thank you, Chase. Excellent work. So please put your questions in Slido. I will be monitoring there for anything the audience wants to ask. But in the meantime, I will ask a question or two. So one thing I was curious about is whether you considered use cases other than this voting use case. And if you didn't study them, what use cases would you most like to look into further that might alter the results?
Yes. So we did look at this sort of like market share case about technology companies. So that was one other kind of topic that we looked at, and the findings were consistent for the bias appraisals, but inconsistent for the predictions there. I think in general, I want this to be applied to sort of more of these real world situations where you bring in people's kind of natural belief about what might happen, or kind of they can rely more on their real world knowledge and use that to make a prediction. Right here, these are really designed to be ambiguous, and so you can't rely on kind of external information. But I think a really key direction of this work would be to look at more of those situations where people are bringing in their kind of real opinions on what might happen, or prior knowledge on the situation, because I think that will kind of also have an impact on how they evaluate the author in particular, and whether they think that the author has that same kind of background knowledge, and also how they might use this text to kind of inform and update those beliefs. And so I think those are kind of two interesting kind of areas where I would want to see how this result holds up or how it changes.
Okay, there's some questions coming in on Slido. Did you study, or are you planning to study the effect of graph literacy on the effect of the text? And do you expect it to have an impact?
That is a great question. So we did not, I think, break down that in the analysis in this study. I don't know if that would have an effect. I think what I'd be interested in seeing is whether in that case people rely more on the text, right? That would be kind of the assumption is if you have a lower graphical literacy, maybe you're using the text to kind of scaffold your understanding of the chart in a different way than if you are able to interpret the chart more visually. But so that would be my guess as to what might happen there. But we did not look at that. And I do think that's an important area to understand just the impact of text overall on some of these decisions, and how they might inform different groups of people using this kind of and relying on it differently. I think that's a super interesting future direction for this as well.
Okay, awesome. There are some more questions, but unfortunately we need to move on. So please take those questions to Discord and have that discussion there.
Will do. Thank you.
Thank you, Chase. Our next speaker is Dilshadur Rahman, and the title of the talk is A Qualitative Analysis of Common Practices in Annotations, a Taxonomy and Design Space. Please go ahead, Dilshadur.
Can you see my screen?
Yes, you are good to go.
Okay. Okay. Thank you for the introduction. To reiterate, I am Dilshadur from the University of Utah. Today, I will talk about our design space of annotations in visualizations. Let's look at this line chart. This line chart shows the number of deaths of despair for two different age groups in the US. But it doesn't say much, right? When we add some text descriptions explaining the trends in the data, it becomes much more insightful. Similarly, in this bar chart, this color highlight grabs the audience's attention and directs them to a specific area of interest. So both the text description and the color highlight are annotations. They help in improving the comprehension of data by highlighting and emphasizing important data features in visualizations. Now, annotations are ubiquitous and important in visualizations. They help the audience build mental models of the data in visual analytics. They are also important for externalizing data, collaborating in data analysis, telling histories with data, and much more. Now, even though they are widely used in visualizations, we still don't fully understand how people use annotations in diverse chart types or the full range of design possibilities they offer. There are some existing design spaces of annotations, but they are focused on a specific context. So it is important to explore different annotation options that are available and how they are being used across various chart types in practice. This information could potentially provide insightful guidance to visualization designers, authors, and tool developers. Our study looks to bridge this gap by finding the answer to the question, how are annotations being used in practice in the real world? And more broadly, what is the design space of annotation based on their common practices? And to address this gap, we propose a design space of annotations by analyzing their common practices. To construct this design space, we scraped 9,000 Google images covering 14 common chart types like line charts, bar charts, scatter plots, pie charts, area charts, etc. And after pre-processing of the data, two co-authors of the paper coded a refined set of 1,800 static annotated charts. While coding, we looked at the different types of annotations that we found in the dataset, how often they showed up in different charts, what are the different patterns of their uses in different charts, etc. Our analysis revealed 7 distinct annotation types. Now, this is a scatter plot showing the correlation between the time spent studying for a particular test and the test scores. This text here describes the positive correlation between the two variables of the chart, and the arrow connects the text to the specific point of interest on the chart. Here, the text description is a text annotation, and the arrow is a connector annotation. Please refer to our paper to know more about the other annotation types. Now, we divided our design space into 3 main parts: why, how, and what. The how section of our design space looks into chart-specific strategies for adding annotation. It guides user in choosing suitable options based on their chart type. These color-coded boxes here, these indicate how often different types of annotations are used across various chart types. Take, for instance, text annotations. They are widely used in all chart types, and all the annotation types, except for the geometric ones, are used in line charts. Now, the why section of our design space is all about figuring out the main goals behind using annotations in a chart. It helps people find the right kind of annotations depending on what tags they want to support with their annotations. For example, someone might want to present additional context about the data in the chart, or they might want to help the audience identify key features on the chart. They might want to help the audience summarize information or compare different data points on the chart. So we also looked at the patterns of which annotation types is supporting what kind of analytic tasks. For instance, here, all the types of annotations are good for identification tasks, while text annotation can pretty much support all the analytic tasks. We also noticed some common trends in how different annotations are used for various tasks and included them in our design space. The what section of our design space focuses on the types of data used to create annotation. In this chart, this red dashed line showing the national average of the test is coming from an outside source other than the data set, meaning it's pulling in information from elsewhere. That's why it is an external annotation. This correlation line, though, it is being calculated from the dataset itself using an algorithm to figure out the relationship between the two variables of the scatter plot. That makes it a derived annotation. And what about the labels inside this rectangle? Those come straight from the dataset without any changes, just showing what's already there. So that's why they are internal annotations. Now let's see a case study of how our design space can help annotate chart in a structured way. Now, this line chart shows the number of COVID-19 cases, deaths, and hospitalizations over a specific time frame. Say the designer wants to help the audience quickly identify these peaks in the data. Now, looking back to our design space, if we check the how section of our design space, it says that all the type of annotations, except for the geometric ones, can be used in a line chart. And if we check the why section of our design space, it says that all of these annotation types that we have found from our analysis can help with the identification tasks. In this case, let's say among all these different options, the designer chooses enclosure, color highlighting, and some text to point out the peaks. Then let's apply these annotations on the chart. Now, these text labels that we just added are external annotations because they come from an external source. they are defined by public health officials to identify different COVID-19 peaks. So they are external annotations. So here is the line chart with enclosure, color, and text annotation to highlight the different COVID-19 peaks. Now, let's say the designer wants to present more context to explain these trends in the data. Now, if we go back to the design space again, if we see the how section, it remains the same because this is the same chart. And if we look at the why section, we see that only text annotations really help present additional information. So the designer would go with text annotations in this case. And then now let's apply the annotations on the chart. Since these descriptions that we have just added also comes from outside sources, probably further external analysis by the designer. So they are external annotations. Now we have the fully annotated chart here. And this is how our design space can be used to annotate chart in a structured way. Now, before I wrap up, I will quickly go over what we talked about today. We don't have a clear understanding of how annotations are used in different contexts and chart types. To address this gap, we proposed a design space of annotation based on common practices of annotations across 14 chart types. But our understanding of how to effectively use annotation is still very limited. As a community, we need more research to fully understand annotations. We need to explore aspects like how annotation affect user comprehension in different contexts, how much annotation is optimal, how professionals apply them in their charts, and how we can facilitate annotation in visualization tools to better support visualization authors. Thank you for listening to my talk. I'm happy to take any questions now.
All right, thank you. We have a couple of questions in Slido. So first, do you think that the empty spots in your design space represent ineffective annotations, or might some suggest design opportunities that are underexplored?
We do not think that we did not explore the effectiveness of different annotations. We just looked at the common practices of annotations, so we cannot comment on the effectiveness of different annotations, but there might be an opportunity to see how different annotations are like playing a role in different contexts, how effective they are, in how they are helping in the comprehension of audience from the charts. So that's a nice future work. That's a super interesting future work for all of us as a community to look at, I think. And that's a very important question.
Okay, another question says, during collecting the data, how did you deal with chart junk or meaningless or misleading annotation? Is semantics of annotation, I'm not sure what they mean by this, is semantic of annotation different dimensions? But essentially, how did you deal with chart junk or misleading annotations?
So when we are looking at, when we are scraping a chart from the internet, we first scraped like 9,000 charts, and then we looked at what charts are annotated and what charts are not. Then the charts are annotated that we then filtered them from the larger data set. But we did not really look for chart junks when we are processing the data. We did not consider chart junk as a parameter for filtering the data set that we used for our design space.
Okay, and then I have a question of my own. I'm curious what you think this work most tells us about annotation support tools that we could innovate for the community to use.
Can you repeat the question?
Yeah, so I'm curious, like imagine I'm a designer of Viz tool and I want to make it easier for people to annotate them nicely. What could I do?
Okay, so I think there is a lot of gap in the literature regarding this subdomain of visualization. I think Chase and people are doing some amazing stuff. We need to understand how different annotations help people to comprehend data. This design specifically can help you to identify, based on your chart types and your tasks, to identify the right kind of annotations that you want to facilitate. But we still have a lot of gap in the literature to understand like what is the different effective annotations for different kind of contexts. So we still don't know that. Well, I think we have to do a lot of like research to understand that, but specifically this design space can help to identify these are the common annotation types that are being used in practice. So maybe I would suggest the users or the visualization designers to use annotations types from these available options.
Okay, fantastic. We need to move on, so thank you very much. Our next talk is the language of infographics toward understanding conceptual metaphor use in scientific storytelling, and it'll be presented by Hana.
Yes.
Hello, thank you very much for the introduction. So my name is Hana Pokojná, and today I would like to present our project, The Language of Infographics, on behalf of myself, Tobias Isenberg, Stefan Bruckner, Barbora Kozlikova, and Laura Garrison. So what we are doing is basically taking a linguistic theory, which is the conceptual metaphor theory, and we're mapping it into the world of visualizations. We're also providing a database for our reasoning of these classifications, and also an exploratory tool which shows the patterns that we have found. We are doing this because metaphors are a way to communicate some unknown ideas, and they're often used in pedagogy, and we're specifically applying this to scientific infographics in 4 domains. So conceptual metaphors are literally devices. They help us understand something that we do not know through something that we already do know. And by this, they help us bridge different kinds of domains. However, there's plenty of cultural differences in these metaphors, as well as individual differences. And they have been previously explored by Lakoff and Johnson, who have stated that metaphors are not just a matter of language, but also a matter of thought and reasoning. So first, when we start with the metaphors, we have to define what is the source, which is something that we do know, and then our target, which is something that we don't know. And this later on helps us with distinguishing between a visual abstraction and a visual conceptual metaphor. So when the source and the target are conceptually the same, here represented by circles, we have visual abstraction. And when the two source and the target are conceptually different, we're talking about a visual conceptual metaphor, such as meme spreading by a wildfire. So here is an example where our source is a glyph of a fire representing a forest fire, which is conceptually the same. So we're talking about an abstraction. And in visual conceptual metaphor, we have source, which is wildfire, so image of wildfire representing the spread of popularity of memes. So conceptually, totally different. So once we decide whether the thing we're talking about is a visual abstraction or conceptual metaphor, we can then classify it into one of the 4 different types. And here I will give you a very brief overview and then show you specific example in later slides. So these 4 different types of metaphors are distinguished based on their complexity. So the most basic one is imagistic, which tells you about the concept and specifically just the graphical similarity, so not about the function. We have orientational metaphor, which tells you about a concept based on its spatial orientation or placement. We have more complex ontological metaphor, which takes something abstract and gives it borders or makes it more concrete. So you can, for example, quantify it. And then we have the most complex one, which is a structural metaphor, which takes unfamiliar conceptual networks and helps it explain through another familiar conceptual network through entailment relationship. This is the infographic I'll be using to give examples by Molmir and colleagues. And here, the imagistic metaphor is talking about the shape of a cell by showing a irregular patch and a wobbly structure. We have orientational metaphor where different stages of cell cycle are arranged in this infinity symbol, which tells you about the cyclicality of the process. We have ontological metaphor where these abstract ribosomes are being represented as copy workers. And we have the most complex structural metaphor where we have a nucleus being represented as a library where you have information organized in a very specific way. The information can be taken out, transcribed, and given back. So our process consisted of defining the terms that I have just mentioned on previous slides. We have then selected our corpus of infographics. We deconstructed and classified them. We synthesized our findings in 2 different artifacts, and we have a summary of findings I will go over later. So our corpus consisted of 2D infographics in 4 scientific domains, so biomedicine, climate, space, and anthropology, and we ended up having 10 to 15 examples per domain. We have deconstructed each of these infographics through another linguistic process, which is called method for identifying metaphorically used words. And we basically deconstructed it into little graphical units. And these graphical units were then classified either into visual abstractions or visual metaphors. And if they were visual metaphors, they were given one of the 4 types of the visual conceptual metaphors. So our synthesis provided 2 artifacts. So first one is the database, which shows the metadata as well as classifications and reasons for our classifications. And the second one is exploratory tool, which also has a live link. And both of these are available on the OSF. So the exploratory tool helps us show the patterns that we have found in these 4 different domains. And when you get to the site, you can choose one of the 4 domains. Then you're presented with this spatiotemporal graph where each infographic is represented by a point. And when you hover over a point, you select an infographic, at which point you have a specific image, you have link, you have other data related to the image. And you also have metaphor analysis. So this little bar chart shows you how many of which type of visual conceptual metaphor is present in this specific infographics, as well as detailed description of each of them. In summary, we have looked at 109 different infographics, and only 55 of them have adhered to our criteria. And in total, we found 131 visual conceptual metaphors. We have found that the anthropology domain had the least amount of visual conceptual metaphors, which made us think that this metaphor use is very domain specific and domain dependent. And here is a really good example of a map that is using kind of minimalistic way of getting ideas across as quickly as possible. So for example, movement across time is represented with arrows. You have thickness of arrows representing number of people, as well as little glyphs that represent important places. These, however, align more with our definition of visual abstraction rather than visual conceptual metaphor. We also have found that the ontological and orientational metaphors are being used the most across all of the domains. So maybe this is the perfect balance for explaining information, at least in the 4 domains we have studied. So here is an example in biological infographic where you have a process arranged in clockwise manner, and it shows you the cyclicality and the beginning and the end. And we also have this space example where expansion of universe, which is something abstract, is being represented by this concrete shape of a cone. And also time is going from left to right, so that's an orientational metaphor. We have also found that effective strategies often work with orientational and ontological visualizations. Effective strategies are visualizations that basically are supposed to make you feel something and have an emotional response, which means that visual metaphors may be promoting effective visualization. An example is this infographic from climate domain, where the color red, which is semantic, doesn't only represent the different temperatures, increasing temperatures, but also red, the urgency of the situation. We have also found that textual metaphors also often cooperate with visual metaphors in infographics. So for example, a rising of sea levels is corresponding with the glyph for sea levels being placed on an escalator that is going up, as well as this warmest day is all the way at the top of the escalator, as well as this red is also representing urgency and the temperature. Very interesting finding is that the boundaries of classifications for some of these metaphors may be a little bit blurry occasionally. So when you look at this infographic through the lens of ontological metaphors as a biologist, you may think that these different steps are representing a phylogenetic tree. However, if you look at it through the lens of orientational metaphor, you can perceive that up is better and down is worse. So maybe there is some sort of negative insinuation with these steps going downwards. But also there is a chance that this was just a design choice. For example, Escher's painting about the stairs, maybe it's not metaphor at all. So in the future, we would like to extend this proposed understanding of our metaphors in scientific communication. We would hope that maybe this paper is going to promote some sort of work towards creating instructions for specific elements within specific metaphor types. We would also like to see whether certain types of metaphors are better at explaining, for example, complex information or simpler information. And of course, our work doesn't go without limitations, so we would like to look beyond our scope of scientific and infographics, and maybe look even at more abstract depictions of data. And I would like to thank you very much for your attention, and here's the paper if you would like to see it.
Okay, thank you very much. So we have several questions in Slido. First one, was it always clear-cut to choose the metaphor types in your table, and what were examples that were hard to categorize?
So as I mentioned before, we have taken this work from the literary world, and Lakoff and Johnson have already identified these 4 different types of metaphors. So that was a nice thing. However, it took quite a few tries to kind of categorize them properly within visualization. And if I go back to this slide, for example, we had a few-week debate over this specific infographic where, you know, some people thought it's ontological, some people thought it's orientational, and it can be, you know, explained as from both points of view. However, you know, there is no wrong or right in this case. So, and there's more examples in the paper with specific infographics.
Okay, great. Let's pick Thomas Davidson asks, do you have intuitions or intend to investigate whether the visual metaphors actually help with communicating information, like to non-experts in particular?
So we have been looking at infographics that are mainly aimed at non-expert audience, and they're being used in schools, scientific museums, and textbooks. So that tells us that definitely is quite useful, specifically for the non-expert audience. When we have maybe more abstract data, for example, some bar charts or different types of charts that would be more aimed at experts, so we could investigate that in the future.
Okay, and I'm going to sneak in one more. Jia Yi Hong says, I wonder how you differentiate the icons with the metaphors. Fire and weather examples seem more iconic.
Sorry, could you repeat that very quickly? Sorry.
How do you differentiate icons from metaphors?
So icons usually go hand in hand with visual abstractions, however, not always. So for example, I think you mentioned medical field. So if you're describing, for example, you want to look at something and you take a picture of an eye, that's kind of the same conceptual field. So that would be an abstraction. However, for example, Preem has an entire paper of different types of metaphors within this medical field. So.
Okay, great. We have many more questions. I'm going to ask you to take those to Discord and have the conversation there. We do need to move on, but thank you very much.
Thank you. Bye-bye.
Okay, our next speaker is Nicole Sultanum, and she is going to talk about From Instruction to Insight, exploring the semantic and functional roles of text in interactive dashboards. Take it away, Nicole.
Hi. Thanks for the introduction. My name is Nicole Sultanum, and I'm here to present work done with Vidya Settler on understanding the role of text in interactive dashboards. We know that text and visualizations go well together. They play complementary roles. Effectively combining them has a net positive effect for communication. Beyond charts and data-driven articles, text in dashboards plays a really important communication role, even for the most minimalistic of dashboards. Just try finding your way around the dashboard without text. What are we looking at? What is this about? So yes, text in dashboards provides that critical connective tissue between all views and onto interactivity. Past work has done well, past and present work, if you include this session, past work and present work has done well characterizing the role of text in visuals for individual charts and in data-driven articles, but not so much text in dashboards. And I would argue that dashboards are in a class of their own. They can vary significantly in communication intent, are often interactive, support open-ended exploration, and usually have multiple views. So it follows that the way dashboards use text would also be unique and worth investigating. And because not a lot of attention has been paid to text in dashboards, we know very little about design considerations or recommendations. And more importantly, in this generative AI wave, where all text authoring is suddenly being automated to oblivion, we lack the knowledge to design appropriate guardrails for large language models. Given this gap, Vidya and I undertook a comprehensive investigation to get a clearer picture of dashboard text use and how we can design technologies for it. We compiled a corpus of 190 publicly available dashboards and analyzed their use of text. We also interviewed 13 dashboard practitioners to learn about their dashboard text practices. And our combined findings led us to derive a typology of dashboard text components from a functional and a semantic perspective, common design patterns for text, recommendations for dashboard text authoring, and relevant opportunities for future research. We start with text components we found, which include dashboard title, present in 92% of dashboards in our catalog, subheadings, section headers, and chart titles, plus other body level components, including interaction guidance, metadata, usually in footnote size, and then content blocks, which are body level blocks containing data-related content. We also found other dashboard components where text plays a prominent contextual role. This includes what we call text data summaries, also known as bands, which is short for big S numbers, and should be self-explanatory. Text-based chart annotations, tooltips, which look like this by default, but are often customized to look more like a sentence, and data tables. Next, to get a sense of semantic distribution, we adapted and applied Alan Lundgaard and Arvind's 4-level semantic model to dashboard content. Level 1 describes text, that has data about data and chart encodings, like in the snippet. But if you step back and think more broadly about what that entails, chart titles also play a similar role. And similarly for level 2 text, which describes low-level statistical takeaways, it also fits text data summaries. For level 3 and level 4 text, we just use the standard application. With these functional and semantic concepts in hand, let's talk about design considerations. And we compiled a list of 8, which we are going to speed through, so please refer to the paper for more details. First, shared practices. Practitioners were not aware of any standard practices for dashboard text, but said there's still a lot of shared collective understanding, largely influenced by exposure to other dashboards. The implication here is we too should learn from examples in order to derive design principles. Next, when reflecting on semantic features of dashboards, we noted a strong influence of layout. In this example, both font size and positioning help reinforce the semantic scope of chart titles, section titles, and dashboard data. And the implication here is semantic and layout features affect each other, and from a content generation perspective, they should probably be considered in combination. Still on semantics, dashboard text is heavily influenced by usage and communication intent. The more narrative dashboards had a lot more level 3 text, content blocks, chart annotations, whereas the more exploratory dashboards lean more towards metric descriptions and user guidance. Since, as for analytic dashboards, users are expected to derive their own takeaways. And the implication here is that dashboard communication goals not only affect what content is provided, but how. Capturing that communication intent would help us offer dashboard creators better, reasonable defaults. Text formatting is the text design feature that practitioners were most conscious about. And on that, we noted the use of partial formatting for things like enforcing hierarchy and function in this example, or selective emphasis on takeaways, or text matching data features like data labels and color maps. And these formatting choices are as deliberate as they are manual. There's surprisingly little support for automating partial formatting in dashboards. So we see, again, an opportunity to investigate formatting practices more in depth, perhaps leveraging text data links. Now, how much content is too much content? That depends a lot on context, but in general, practitioners told us they lean on minimizing big walls of text. This is particularly true with dashboards like this one on the right, the more analytical business-oriented ones, which are likely to be used regularly and don't usually need a lot of front loading. Either way, additional information when present is often nested under tooltips and sometimes overlays. Implications are: consider conciseness and ways of tucking content away. Speaking of user guidance, we saw many embodiments for guidance from the static text version, the most common one, and a few icon-based variants to overlays again, and a couple dynamic step-by-step guides. Among our practitioners, dashboard guidance was seen as a generally good thing to have. That said, one of them mentioned there are trade-offs to consider, the fact that they take up space but are only useful once. On-demand content, like these examples on the right, would be a decent solution for this problem, but they are not always discoverable, and they're also complex to craft. Bottom line is, guidance is good, but there are trade-offs, but also more low-hanging fruit for us. And on the topic of dynamic things, almost half of the dashboards implemented some form of dynamic text. The most common ones you saw were chart titles updating with filters, like in this example. But we also saw a few dynamic takeaways, like the conclusion segment in this Bitcoin investment simulator. Dynamic takeaways were, however, pretty rare and highly templated. In summary, there's not much out there for dynamic text, and that's yet another opportunity space for text data links and overall more interactivity. Finally, we found other aspects of dashboard communication that complemented or transcended text. We saw icons communicating semantic and functional aspects of the dashboard. We saw multilingual dashboards, which we thought was cool. And also we reflected on aspects of reading order, which are somewhat ambiguous in dashboards, but have concrete implications for things like screen reader accessibility and cognitive support. And to us, factors like these showcase just how rich the space is for dashboard text considerations and tell us we barely scratched the surface. Reflecting on all these practices, we took a stab on what dashboard text recommendations could look like. We built on Vidya and Melanie's, the session chair's, past work that proposed 39 conversational heuristics for dashboard design and transformed them into 12 heuristics for dashboard text. They are organized in 4 groups: analytical support, semantics and context, presentation aspects, and navigation support. Vidya and I spent countless hours over many weeks poring over all dashboards in our corpus to assess these heuristics and find agreement in our pair assessment. It was a long process, but it gave us a lot of insight on how aspects of our typology and findings fit into each heuristic. And you can read more about it in the paper. But one thing that helped us a lot was crafting these detailed rubrics to more objectively assess each of the 12 heuristics. And this is yet another resource at your disposal. And last but not least, we reflect on opportunities for future research. A few promising directions include dashboard linters, or ways to sanity check communication and presentation aspects, building on examples and repurposing elements from one dashboard to another, helping practitioners craft content to explain data provenance and metric calculations, expanding guidance capabilities, perhaps via user adaptive approaches, using text data links to automate formatting and interactivity aspects, and being more creative with dynamic text and interactivity overall. Here's a QR code to our paper blog, supplemental materials, and a shameless plug that Tableau Research is looking for summer interns. Happy to take your questions.
All right, thank you, Nicole. So please put questions in Slido. While we're waiting, I have 1 or 2 of my own. So I wonder if you could say more about tool support for dashboard annotations. You mentioned some opportunities for future work here, but what could tools like Tableau do to make it easier for authors of dashboards to add textual annotations nicely?
I mean, before we even get to annotations, I would say that even just adding text blocks is a really painful process. There are a lot of limitations on font family, styling, positioning, boundaries. And one thing that dashboard creators often resorted to was, instead of using native text, which is screen reader friendly, they would actually use images. They would, create a content block in Illustrator, for example, which, could, reflect the vision that they had for the dashboard, and they would use that instead of native text in Tableau. So before we even get to chart annotations, we need to figure out, basic text. So that's where I would start.
Okay, great. In Slido, Richard Braff asks, many of the annotations use typographic hierarchy, size, span, weight, etc., to associate text with graphics. How can you bring type design guidelines into this?
Oh, that's a wonderful question. Our research hasn't gone that far. But I mean, Richard has done amazing research on mapping typographic features or typographic dimensions into data dimensions. And that's something that we would love to explore as, extensions to Tableau. Again, current tools are very limited, so the sky's the limit in terms of, what we could add to dashboard, to elevate dashboard text as a first-class citizen.
Okay, great. And I have one final question. You mentioned sort of capturing the intent in the text and using that to align it to your categories. How could you do that automatically?
That's yet another wonderful question. We don't know, or whether there are potentially different ways of doing that, but more importantly, we probably have to start from categorizing intent, which again would entail further research on existing dashboards in the wild, and proprietary dashboards, which are also not contemplated in our study. And from that understanding, then we can start thinking about ways of, okay, what are reasonable pathways for eliciting that information from the user. That's probably where I would start.
Okay, fantastic. We need to move on. There's one more question that you can follow up in Discord. In the meantime, I'm going to move on to our next speaker. Thank you again.
Thank you.
So next up is Yu Liu, who is going to be speaking about I Came Across a Junk, Understanding Design Flaws of Data Visualization from the Public's Perspective. And Yu, please go ahead and join us.
Hello?
Yes, we can hear you.
Sorry, I was out for a second. I don't know why, so I rejoined. Okay.
No problem. You're on now, so please go ahead and give your presentation.
Okay, so I'll share my screen first. Okay. So, hello everyone, I'm Yu Liu from the University of Edinburgh. Today I'm presenting our work titled I Came Across a Junk, Understanding Design Flaws of Data Visualization from the Public's Perspective, completed under the guidance of Dr. Xing Yulan from Fudan University. So when we first think of flawed visualization, we of course think of the chart junk by Edward Tufte. Tufte criticized decorative visualizations and argued for clarity and simplicity. However, this issue of flawed visualizations dates back further in the 1950s. The book, How to Align with Statistics, outlined various misleading charts, selling over 1.5 million copies, showing the importance of this topic across academia and industries. So in our paper, we aim to revisit this fundamental issue of flawed visualization. Currently, there's no unified definition for flawed visualization. So to avoid confusion, we define design flaws as any visualization design that hinders information display, whether it is intentional or not. Let's look at some examples. 3D chart often distorts space, reducing accuracy, and the rainbow color scheme creates confusion due to too many hues. While the truncated axis, you can see the x-axis doesn't start at 0, misrepresent proportions as seen in the bar chart comparing red and blue columns. These are common examples when we mention flawed visualizations. But there are newer issues as well. Let's look at this stacked bar chart. It feels odd because it distorts a human neck. The issue isn't just data accuracy, but a violation of social norms, creating a discomfort on a psychological level. This shows that many aspects of flawed visualizations are still unexplored. In recent years, scholars have proposed taxonomies for design flaws. Through our literature review, we identified 3 research gaps. First, Many flaws are not covered by existing theories, as I mentioned above. And second, current studies lack systematic approaches. And third, most research focus on what design flaws are, but few of them ask why they occur. We aim to address this. So we open-coded data from VIS.wtf, a platform that collects flawed visualizations, as you can see in the right image. After scraping 2,227 visualizations and analyzing user comments, we identified 76 design flaws and grouped them into 3 high-level categories and 10 subcategories. They are the red, misinformation, visualizations that convey distorted or deceptive information. The blue, uninformativeness, charts that lack meaningful data, making interpretation difficult. And the green, unsociability, visuals that create discomfort or social awkwardness. Let's look at some few specific flaws. First, we have the most common issue, data visual disproportion. Here's a chart showing the support for different election candidates. You can see that the blue section represents 9.4%. It's almost as large as the 60.3%, and it even surpasses the 14% on the right. And this flaw is quite interesting. At first glance, it looks like a regular bar chart. But when you look closely, you'll notice that the data and visuals don't match. Then it hits you, it's really not a bar chart. The author just highlighted numbers, which creates ambiguity. This aligns with our M2 ambiguity category, where the visual symbols are unclear when conveying data. Anyone with red-green color blindness would definitely dislike this chart. And this chart is about shoe color frequency. But if you look closely, the green bar in the middle actually represents black. The text doesn't match the color of the bars, which feels quite odd, even though it's not technically distorting the data. And lastly, this visually striking chart was supposed to be a stacked bar chart, but because the cow is cut in pieces, it ends up being quite uncomfortable to look at. By analyzing the frequency of these flaws, we found that high-frequency design flaws occur across various tasks. We also identified 36 new design flaws, particularly in the unsociability category. This suggests that the visualization is not just a technical tool, but a medium intertwined with social factors. We also found that decorations impact visualization in a more complex way than previously thought. While discussions about chart junk often focus on decoration as a negative, we didn't see it as an inherent flaw. Instead, we analyzed how decoration can interfere with data communication, as shown in the 4 examples below. First, a gradient effect on the bar chart's end can obscure the accurate interpretation of bar lengths. Second, decorative figures can block comparisons between bars. And in the third example, the author probably meant to highlight certain data, but this distorted the data mapping proportions. Lastly, the visual itself as a decoration. We can see that the bar chart and pie chart on the right don't encode any data and have no connection to the accompanying text. For more detail, please visit our website, flawviz.github.io. We have 76 cards explaining each flaw in detail, with new ones marked in the corner. And this is our corpus. So after establishing the taxonomy, we want to further understand why these flaws occur. Ideally, we'd ask the original authors, what happened? Why would you make such visualizations? But that's impossible. So instead, we used elicitation method with professionals who recall their similar experiences from their own work. We conducted 5 focus groups with participants from diverse backgrounds, such as designers, programmers, and data journalists, all experienced in visualization. So we identified 7 main reasons for design flaws. For example, R1, achieving communication intent. One participant, while reviewing a political election visualization, remarked, politicians always want their own data to look good and their opponent's number to be seen as low as possible. This could explain the disproportionate data to visual mapping we saw earlier in the election chart. And another example is R6, compromise with clients. A data analyst mentioned many 3D charts are created because they look cool, which has a special appeal for clients. The designer added, same here. I've always had to come up with ways to meet the cool requirement, even though it compromises scientific accuracy. We also extended the classic information visualization reference model to include social context, as designers are influenced by various stakeholders. We also identified 9 future research opportunities. For instance, O3 highlights that most existing tools for detecting visualization errors are code-based, but few are pixel-based visualizations. So this presents a research opportunity. Additionally, O6 and O7 suggest that many design flaws stem from a lack of literacy. Therefore, understanding designers' needs and developing suitable educational materials and tools would be a promising direction for future work. For more detail, please visit our website, flawviz.github.io, and our paper is also available on archive. Thank you. Now I welcome any questions.
All right, thank you. So we have a question in Slido. Nargis Mayar asks, how did you incorporate decorative figures into your study? And what sources did you use for those decorative visualizations? And then how diverse was your collection?
Okay. Let me back to the slide. So you can see the picture on the right. Our dataset is actually from an online platform that everybody can contribute. It's called What the Fuck Visualization. You can just type in and see how their dataset are. Basically, what we do is we scrape our data, scrape their data, and we clean it. We remove those duplicate ones, and we remove those are not count as visualizations. So this is our data set. And
okay, great.
And
how diverse was it?
What?
How diverse was that collection?
Yes. So we have basically every chart you can think of, and many topics. We also have labeled them like politics, education, leisure, sports, music. It's also very diverse in topics.
Okay, great. I was wondering, it was interesting that you kind of categorize those problems in the charts and how frequently they occurred. I wondered if you could speculate on whether those frequencies represent the frequencies that are out there in the world beyond W2F visualizations, or whether they might be influenced by some charts being more offending and therefore more likely to be uploaded to that site.
That's an interesting question. Let me repeat your question. You're thinking that the data set in this website doesn't actually represent the outside world.
Might not represent the sort of relative frequencies of different problems in the outside world, because those that are more problematic might be more likely to be included.
Actually, when we were doing this paper, we didn't see many others doing it. So we are basically kind of the first to do these things.
Yep.
So
Okay, I think you has frozen. And I think we need to move on. So in any case, thank you. It was a lovely talk, and we're now going to move on to our next speaker. So the next speaker is Hanning Shao, and the talk is entitled Kata Anno, an ancient catalog annotator for annotation cleaning by recommendation. Take it away, Hanning.
Hello, can you hear me now?
Yes, we can.
Okay. Hello everyone, I'm Hanning Shao from Peking University, and I'm glad to introduce our work, Catalog Annotator, Asian Catalog Annotator for Annotation Cleaning. First, I would like to show you the catalogs of Chinese ancient books, which is like in this picture. They are in texture forms and are recorded by the authorities, scholars, or individual collectors in ancient times. And you can see that each sentence here records one type of book, like this one. It says the comments of I Ching. This is this is a book, has 12 chapters, and there are 3 different versions by different authors. This information can be extract and from the data table like this. And this is catalog digitalization. For scholars from classical bibliography, they do this to reconstruct the works in the history and to understand the production, the organization, and evolution of academic knowledge in ancient times. However, there are also challenges, like in this case, there are 3 different catalogs from the different dynasties, Han, Sui, and Qing in ancient China. And they are, you can see that these 3 catalogs all have recorded this book as highlighted. And you can find it is recorded differently in these 3 catalogs. And if directly extracting the information from the original text, you will obtain different data entries. They have different values in these dimensions. So there are additional steps for experts to standardize and to unify these entries since they point to the same book. You can summarize the requirements for the annotation here. It should extract the book attributes to filling up missing information and to make sure that the entries, the annotation should be consistency. And the pipeline for the catalog digitalization also needs extensions. Here, the unification and standardization. And our work focused right on these last steps, the ontologization of catalog annotation. We first interviewed the researchers from classical bibliography to learn about their traditional workflow. They use tools like Excel to handle this data table. They sort this table according to different dimensions like the title. They sort the data entries with the same or very similar titles will then be reordered to neighborhoods, and the experts can then check and update them together. And after that, they can change to other sorting keys like the author. There will be this will be done repeatedly until nothing can be updated. Of course, this workflow has limited efficiencies, especially in this step. Considering that in the general catalog by modern scholars, there are over 118,000 books, and let alone each book can be recorded in multiple catalogs, and more catalogs from personal collectors have not been included in this book. So we need more efficient method to do the annotation cleaning. And the key idea is to avoid repeated efforts on one entry. If we can identify all relevant entries from this data table towards the one currently being annotating, the experts can then easily update them together and keep them unified. So we try to improve this workflow. We add an embedding model here to calculating the relevance entry from the table and to recommend for the users, so that the annotation can then ideally be done through one single pass. Then the key problem is how to obtain such a good embedding model. Here we adopt a constructed learning framework and conduct a two-step training. Based on a pre-trained BERT model, we first conduct unsupervised constructed learning to learn to let the model to get familiar with catalog data, and then supervised constructed learning for deeper understanding of the relevant entries. For the unsupervised constructed learning, we use model drop-off techniques to construct the positive pairs for constructed learning, where the model will randomly ignore some outputs of a small part of the network. And then for the supervised constructed learning, we adopt a technique we call dimension dropout. There are 5 dimensions here in each data entries, and we can get 13 situations when we set each dimension marked or unmarked, excluding the case that all 5 dimensions are marked, so that we can get 13 embedding vectors. And here the vector 0 stands for the situations that all 5 dimensions are visible. And thus, 13 pairs can be generated for the constructed learning, and we get our final fine-tuned model. And with this model, we can form the embedding space with all entries from in the data table. And for each query, for each query, we adopt a similar dimensional dropout method to generate 13 vectors. And for each vector, the KNN results can be found in the embedding space as relevant ones. We finally reorganize all these results and choose the top K ones as recommendations. And we use the benchmark to check if our model and also the recommendation algorithm can find the entries that exactly refer to the same book. We compare our fine-tuned model with the base model, and we also test the model on the different situations when different dimensions are marked. And here, the original text is always here, and we set it visible all the time. And you can see that our fine-tuned model performs much better than the base model. And when all dimensions are provided, the model performs very good. And there are also interesting things that the author dimension seems to contain more information than the title dimension. And this is due to the pattern of our test data set, since we use the catalog data by modern scholars who tend to include the title in the original text when recording these books. And we also have a system for annotators. On the left is the catalog structure view, and catalogs and the book items are displayed in the original hierarchy structures. And on the right is the processing list. Entries are displayed in table format here. We also decorate the table cells to enhance the similarities between entries and their recommendations. And when hovering, we highlight the text through changing their style and color to help with the text comparison. And here is a single case. This entry comes from the subcatalog E, which means this book, all these books in this catalog are related to Zhou Yi. So the experts would add Zhou Yi to the title cell. And the original title, the Zhang Ju, only means comments. Then these recommendations will be updated accordingly. At this time, from the original text, the expert can find the family name of the author and then add Mong, the family name of this author, to the author cell. And finally, and this time, the recommendations contains very similar entries like these. They are the entries that refer to exactly the same book. The expert can then finally complete the annotation of these entries and taking all these recommendations as reference. The experts gave positive feedback to our system. They believe that this intelligent system for the ontologization step is useful, since previous tools most focus on the automatically data extraction, and they also satisfy with the recommendation performance. We think that this method can improve the efficiency and also make it possible for crowdsourced annotation, which previously struggles with the low quality annotations. And when it comes to errors that automatic methods may arouse, the experts believe that as long as they do not harm the overall effectiveness, they will be helpful for them. And let's make a conclusion. This is the work we collaborated with domain experts, where we identify their challenges and requirements and try to improve their workflow with our techniques. For the system, it can be more proactive. For example, we can do recommendations according to users' operations, or to automatically identifying the inconsistency in the data table. Besides, the system operation records are also valuable, since they are high quality training data for the model, and so that we can improve our system's performance. At last, we would like to thank Professor Xianbing Sun's team for they provide us with the catalog data and participate in our expert interviews. That is all for our work. Thank you.
All right, thank you. So if there's any questions, pop those into Slido. In the meantime, I'll ask one. So you designed this for these specific scholars and these specific Chinese texts. What aspects of it would generalize to other kinds of digital humanities work or other kinds of text? And what aspects are very specific to this use case?
Yes, this work is original focus on this Chinese Asian book catalogs annotation, but it solves the questions, the problems of the disambiguation in text annotation. So we think this is a common problem in such like digital humanities area. You can find these the requirements of this disambiguation in many cases, like for the geography, they have different names for the same location, or they have different people that have different names, but they point to the same person. So this we think this is a common problem. So we do this to have this, but we this work also of course focus on the catalog annotation.
Okay, great. And then my next question is, have you learned anything more since the end of submitting your paper? Have the experts been using it in practice or anything like this that you have gained more insights?
Excuse me, gain more
So
insight on what?
I'll rephrase my question. Have the experts that you worked with been using this tool in practice? And if so, what did you learn from that?
Oh, yes, they have tried our system, and basically this, as I said, this is a collaborate with this domain expert, and they have little ideas about what visualization is and what our system, our intelligent method can do. So we just provide the potential of our system for them, and they find that, wow, this is interesting and this really works. So, and also there are attributes to the errors in these automatic methods, which are always aroused by these automatic techniques, that these things, if these techniques can help with the most case, they can tolerate these errors in minor cases. And I think this can give more potential for these kind of collaborative works.
Okay, fantastic. Well, thank you, Henning. This concludes our session on text annotation and metaphor. Everybody enjoy the conference. Thank you.